Hello team, today's challenge is Spiral Matrix, where we're given a two-dimensional array, an array of arrays, and we are asked to flatten it, but not in the regular sense where we go 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we need to flatten all of the outside edges, then all the inside edges. So 1, 2, 3, 6, 9, 8, 7, 4, 5, and so on, etc. with all these other examples as well. So starting from the outside, we go clockwise until we hit the inside, okay? Lots of examples on this. One has it measuring the outer boundaries, and then every time you turn directions, you subtract one from the outer boundary so that you can never go back to that row or that outer edge, right? Until you get to the middle, at which point you're done, right? Another one that I saw was one where they take the entire outer edge like a donut, right? So taking that entire outer edge, doing something with it, and then the next inner square and the next inner and the next inner until we get to the middle, right? Kind of like a lollipop, I guess, right? Working your way in until you get to that delicious center. Something. Metaphors are escaping me today, apparently, but hopefully that makes sense. What I want to do, though, is I want to cut this first row. Okay, I just want to slice it off. And then I want to rotate whatever is left so that 6 and 9 become the first row. And then you have 5, 8, and 4, 7. And you cut or slice off 6, 9 and add it to this row. And then rotate it again so that 8, 7 are at the top. Slice those away, put those on. Slice the 4, put that on, put the 5. So that every time we do it, and all we need for that is a way to rotate it. Well, we've already done that, right? At least, hopefully you've done that. That was over here way back in September 6, 2025, where we were asked to rotate clockwise, okay? Now, what we want to actually do is we want to rotate it counterclockwise, okay? We're counting in a clockwise direction, but we're actually rotating in a counterclockwise direction. Imagine the Matrix movie, not your eyes. So we're starting at 1, and then we rotate it so that now the 2 is underneath the cursor, and then the 4, and then the 3. So we want to rotate it counterclockwise, okay? Which means we needed to do some stuff. And in fact, when I did this, thankfully, I actually did explore being able to twist both ways, okay? Being able to spin it both ways. So as a default, I set it to clockwise, right? And I used a reduce and a for each to basically send individual values to the correct index of that accumulator, okay? And we just fill it all in, and depending on if it was clockwise, right, we could just use the index directly. Otherwise, we had to do a little bit of math to work from the opposite end. And then again, for the placement, if it was clockwise, we put the element at the beginning. Otherwise, we put the element at the end, right? And this worked. It worked great. So no problems. If you have your own solution, you can do the same thing. What I'm about to do, I'm about to copy and paste this into our solution, okay? So right up here, pasting it. Also, I mean, if this is the first time you've seen it, there should be a link, right, to that video. Go and watch that one too. Pretty cool stuff. And it will hopefully explain this better than my 30-second rant. But with that, everything inside of here gets really simple in a hurry. Now, we are going to use recursion, which means that just like a while loop, right? If every time you use a while, think, what is the exit? Otherwise, the while loop runs on forever. Well, it's the same thing with the recursion. If you don't have an exit, if you don't have a final proper return, then it will just keep going around in circles, which is not what we want. So right off the bat, I'm going to start off by checking matrix.length. I'm going to see if that is equal to 0. If it is, then we return an empty array. Now, if matrix has a length of 0, then matrix and the empty array are functionally the same. They aren't the same spot in memory, but they both have no elements, which means that you could type matrix in here too. Depends on how you feel it's more clear, right? Down here, getting rid of some of this, cleaning this up, thank you. We are going to set up our rotated array, okay? And remember, this is based off of that slice, the taking just a piece. Okay, I'll explain that better in a second here, but let's just go and do it. So rotate matrix, I realized that I did not change this name, but I really want to because rotate means nothing. Okay, so rotate matrix, and we are tossing in matrix dot slice. We're slicing everything from 1 to the end. So every row except the very first one. That's what we want here. Okay, and then again, because I set this as a default to clockwise, I want to toss in CCW for counterclockwise, though really the way that I set this up, you can toss anything. So hint, hint, okay? But right here, CCW is what I'm going to do because it's descriptive, okay? At which point we just put it together. So we have dot at 0 and then concat spiral. So we're tossing in all of this spiral matrix, just copying it. And what are we tossing in? Well, we're sending in rotated. So every time we're rotating, taking the top, rotating, taking the top, rotating, taking the top. Technically, with recursion, we do it backwards, but it all works out in the end, okay? And with that, it works. Now, something that I've been thinking about here as I've been preparing for this video is this right here. I think we grab that first row and then we keep concatenating onto it, which I think is actually going to change the matrix itself. It's going to change that first value in matrix. So what I would do here is I would hedge my bets by making this a brand new array, just to be sure, right? Just to be sure. But at this point, again, we're done. And the question is, what have we done, right? Well, if I grab this comment, it looks a lot like this. We started off with our array, okay? Our matrix, sorry, our array of arrays. And then we sliced off the top and rotated the rest. So we get this shape, 6, 9, 5, 8, 4, 7. And then we sliced off 6, 9 and put it on the end. Here it is. And rotated again, 8, 7, 5, 4. Sliced off 8, 7, put it on the end right here. Now we just have 4, 5, right? Because of how it rotates. Tossing the 4 on there to the 5, adding the 5. It's an empty array. We exit and we build it back up, at which point we are done. Okay. So that is that, right? And yes, it used a little bit of recursion. I feel like it's pretty clean. I did hint, or maybe I didn't, that there's going to be a lot of loops on this one. And there is. Every time we enter rotate matrix, we're in it for all these loops, right? So I haven't tested performance on this. It might be slow, but it feels pretty snappy for these tests. So I'm not too worried about it, but you let me know, okay? Again, not every solution, just one hopefully good solution. Did you like it? Did you hate it? Did you find another way? Let me know all that stuff in the comments. Otherwise, today, this has been Spiral Matrix, and I will see you tomorrow.